My name's Cory Minton. I'm with Dell EMC, and my friend here is
Jenny Hollfelder from Splunk.
And we're going to walk you through some things. First thing I want to do is call attention. If you haven't been by the Dell EMC booth yet, we have this cool thing going on where you can find a ninja. You get this card, and you go find 10 people that look like me in this blue shirt. There are EMC Splunk ninjas. You find them, they'll give you a blue sticker that goes on the back. Once you've got 10 of those, you drop the card by the booth, and you'll be entered to win a really sweet Dell laptop. So any of you are here who have your card, if you'll on your way out, we can give you a sticker. We're not going to give you 10 because there's probably 10 of us in here, but we'll give you one. If you don't have a card or don't have a sticker, please stop by the booth and come hang out with us. As is probably pretty normal, we don't intend to make any forward-looking statements or commitments that you should hold us to. So just be aware that we're just two engineers trying to do a good job. And if we say something wrong, don't come after us legally. Okay. All right, so my name's Cory Minton. As I said, I'm a principal systems engineer for EMC. That just means I'm a big geek. I am part of EMC Elect, which is our social ambassador program. And I have the unique privilege to lead our global ninja program. And basically that's a team of about 40 SEs we'll talk about in a little more detail that are focused on helping customers deploy Splunk on top of Dell and EMC, as well as derive value from their Dell and EMC platforms with Splunk. I am certified. I don't have it on me. I am certified, certifiable also. Background in consulting. I'm an engineer and a geek, as I said, and I'm also a professional chef on the side. However, I have never been paid in cash. It was only paid in additional meat. So if anybody's curious, we can talk about that later.
So you don't have to pay taxes on it, is what you're saying.
Well, yeah,
okay.
Clearly I'm a terrible person.
All right.
This is you.
Hello, so I'm Jenny Hollfelder. I'm a sales engineer at Splunk in the Global Strategic Alliances team. A little bit about me, so I've been at Splunk for just about a year. Prior to coming to Splunk, I worked at a couple of different companies, and before that I was a Splunk user and customer for about 8 years. Super fan, still am. Since I've been at Splunk, I've done a bunch of the education courses and certifications. I know a number of you were in Splunk University earlier this week. Dean, can you hold up my badge with all the... You too, if you've got certifications, you can go to the registration desk and get your little pins that say that you've been certified, or certifiable in Cory's case. So my background is in Linux administration. I used Splunk for operational intelligence, and when I got to Splunk, I learned about how many more use cases there are for it. So it's been really exciting kind of learning about that and seeing how much we can do there. I have a bachelor's in computer science, and I'm not a professional chef. I'm a professional hooper on the side, but not really. My hoops are over there. If anybody wants to try after the presentation, let me know. I'm thinking I'm also going to bring them to the party tonight. So anyway.
I tried, I failed, so don't feel bad, just so you know. Well, thank you, Jenny.
All right,
I appreciate
thanks.
it. So Jenny's going to step down for a second. She's going to do the hard part, which is we're going to actually do a live demo, which is super exciting. And we're going all the way to Australia to do that demo, so we'll talk about that in a second. But what I wanted to do is just spend a few minutes with you talking about some of the macro trends that we're seeing from a Splunk perspective, and then dig into some of the specific reasons why Dell and EMC care and why you should care about the relationship that we have. First of all, I think you probably heard in Doug's kickoff that Splunk is no longer this kind of corner case application. It's no longer this small use case piece of technology. It is very much an enterprise machine data fabric. And when it becomes an enterprise, when anything becomes an enterprise application, we have to start applying some traditional enterprise IT requirements against it, right? We have to make sure that it's highly performant. We have to make sure that it's highly available. We have to make sure that the underlying infrastructure abides by some of our traditional IT models, but at least that we're evolving our IT organization to support these new and exciting applications. And as Splunk grows and it becomes more of an enterprise application, we're seeing that the use case growth and the data growth starts to challenge some organizations at scale from an efficiency perspective and how do I manage this large-scale infrastructure. And so EMC and Dell are really excited to be committed to helping our customers and our partners build and deploy infrastructure that runs Splunk really exceptionally well in an on-premise or hybrid environment. As we talked about, right, cloud is cool and cloud is going to continue. Many organizations will not be able to adopt cloud for Splunk, whether it's because of the data governance requirements, right, regulatory or a very litigious environment where that's not in vogue. Or maybe it's in one of those environments where the provenance of the data, right, where the data starts from, the vast majority of it is in a particular site where it makes sense to coexist that machine data fabric in that location. So we help customers deploy on-premise and hybrid infrastructures to run Splunk really, really awesomely, okay? Many customers, they start off with Splunk, and many of you have probably kind of seen this if you're a Splunk customer and you've grown. Splunk scales really beautifully, right? One of the key value propositions of Splunk is its ability to scale linearly, right? From desktop to thousands of machines. But that's not always it's not always a perfect linearity in terms of how it grows, right? Sometimes my requirements may change in my Splunk usage that it really drives a performance need for my infrastructure. I don't need necessarily more data, I just need more performance. And the things that drive that are things like, well, volume and ingest, right? So a certain number of gigs per day can be handled by any particular indexer. If I'm wanting to increase search performance, if any of you attend like Deep's architecture sessions and some of the other ones, they talk about the idea of if you want to improve search performance, the best thing to do is oftentimes add an indexer, right? And if you add more users, or if you start to look at some of the really cool premium applications that Splunk is launching, specifically some of the ones Doug talked about today, which is enterprise security, super cool, but it has an impact on your underlying infrastructure that you need to account for. Same thing holds true with things like Palo Alto Networks app, Exchange app, the VMware app. If you look at ITSI and the machine learning toolkit, if you deploy those, they do have additional performance requirements that you need to take into account in designing your infrastructure deployment. Now, oftentimes Splunk will grow then purely from a capacity perspective. They don't always grow in time and together, right? Volume of ingest clearly grows both, but what happens if I don't actually ingest more data? I just want to keep the data longer for some reason. What if I want to run like ITSI and I have this statistical principle in my head, which is if I keep data longer, it means I can get a bigger sample size against my population, so my likelihood of predicting something gets higher. So long tail, keeping data longer can help enable some of those really critical, cool premium apps like ES and ITSI to actually operate better. And then if you're doing things like index or clustering, has a kind of a big deal impact on Splunk's sizing and how much storage it will consume. And then if you're doing, again, these big apps, it will drive performance and capacity requirements. So in the world of Splunk, what we typically talk about is you have capacity and performance as these two kind of X and Y planes. So the way most folks deploy Splunk originally is they start with maybe it's on their desktop or laptop, or maybe they just have one VM up and running. And so you got some storage, you got some memory and compute, you got one instance of Splunk, right, single instance. And then all of a sudden you grow it and you deploy Splunk on it, and you say, well, actually I want to grow. So what do? You buy another server just like that one, and you deploy it, and then you deploy another one, until you finally get to 10 or 20 or 50 servers in your indexer environment, and you've scaled performance and capacity very, very linearly. But are your requirements always scaling with this perfect linearity? Maybe. Maybe they aren't. What happens if you want to do things like, I don't know, as we said before, I don't want to change my capacity or my ingest, I just want to start using ITSI or ES or UBA. Well, that's going to drive up my performance requirements, but it doesn't necessarily mean that I need more storage. So why would I grow and buy more storage if I don't need it? And the same thing holds true on the other side. If I have a need to extend my retention period on specific indexes for whatever reason, why would I go buy a whole bunch more servers to get to that storage capacity when I actually didn't have that need? And the reality that we see in most organizations is that there's not really like one simple answer. It's that, well, it depends by index, and I got a lot of different challenges. And so scaling in this perfectly linear model in a world where our needs are not perfectly coupled and linear can be kind of challenging. So the thing that we're going to talk about with our Dell EMC story, most of it is really around this concept of decoupling compute from storage. And that can be not only in the cold sense for retention periods, but also in the hot warm sense and the ability to use modern enterprise IT technologies to power Splunk in a meaningful and cool way. But let me give you an example. I love eye charts. Does everybody else? No, I'm kidding. This thing's awful to read. I will give you a copy of it if you want. There are real numbers in there. Basically what it is on the x-axis, we've got retention going from 0 to 10 years, okay? And on the y-plane, we've got ingest rate going from 0 to 10 terabytes. Now, if you assume that a traditional server, let's say you buy a Dell XD790 server, a traditional server that meets Splunk's reference hardware requirements will have generally at most about 10 to 15 terabytes worth of disks in it as an average, right? It doesn't hold true on everything, and if you have exceptions, I get it, but let's just use it for an example. So if I hold that true, that I've got about 10 to 15 terabytes of raw disk, call it 8 to 10 terabytes usable, and I've got that reference server that's got 16 cores, 16 gig of RAM or more, then the red space here, what it values or what it's showing you is that if your ingest rate is over 200 gig a day and your retention is over 6 months and you're using DAS in a server, you're buying too much of something. You're buying too much of one resource or the other. You're buying too much storage. Right? If I scaled in my retention periods a long period, I got all these servers and I went on this bottom axis where my retention is really high, my ingest is low, I have a ton of compute that I have to get to in order to achieve that capacity. And the same thing is true on the other side. If I've scaled, I got tons of servers just for the purpose of performance, but I had to add disk every time because I like symmetry in my server, I'm adding too much disk that I don't really need. So there's a power in decoupling. Now, Splunk is a great application. Their maturity around data management is very, very high. And they offer something that they call the index architecture that we like to take advantage of because it helps customers solve this problem. So we all know that there's hot and warm data. It's in your home path. And if you attend a lot of the sessions, you'll find out that, and I've heard Simon talk about it at the Partner Technical Symposium, heard Deep talk about it a few times. They've done this study where they basically figured out that across customers, about 95% of all searches will go against data that's 7 days or younger, right? It was ingested in the last 7 days. Does anybody think that's probably a pretty accurate statement? Right, it's not hard to figure out. With the use cases, it makes sense. Okay, so if that's the case, why wouldn't I invest really, really heavily in having a hot and warm tier that absolutely optimized that 7-day performance window? Or maybe if you're scared of 14-day performance window, right? Optimize that tier. Invest in technologies like Flash in a server, all Flash appliances, NVMe data fabrics, right? Technologies that are hardware-based, but that absolutely add value to the software, okay? And the same thing holds true that if 95% of my searches are going against data that is 7 days or younger, what am I doing with the data that I keep for over that 7-day period, and why am I keeping that on a very high performance tier of storage? Well, Splunk allows you to do this thing where in cold, you no longer have to use direct attached storage or block-based SAN. You can use much lower cost of ownership technologies like NAS. And you get away from some of the concerns around NFS locking and other things that concern people around running NFS for hot and warm, which you shouldn't do, just so we're clear. You can run a NAS for cold. We're clear, you shouldn't do that. So NAS for cold is super cool because I optimize my cost per terabyte. I can use the scale-out technology, and that's a good thing. In frozen, many people end up going to frozen, and they go to frozen because it's cheap, right? I can put it on a dead medium like tape. But again, if we talk about those premium applications like ITSI or ES, why wouldn't I try to optimize my cost for cold so that I can keep that data searchable so ITSI or ES can use that data and actually derive value from it to build my models? Why wouldn't I keep that in a cold tier that I just continue to scale out? If I send it to frozen, it's no longer valuable. It's really only there for retention. So our argument is try to build a very, very high performance hot and warm tier, invest in those technologies, and invest in a scale-out technology for cold that allows you to optimize that cost per terabyte and optimize your usage, especially in those premium app use cases. So I know you were waiting for it, but there is an EMC value proposition here. And it goes good with cold beer. EMC and Dell are committed to giving you products and solutions that deliver on this idea. And we do that in a couple of ways. We have optimized shared storage offerings, both all-flash, scale-out, software-defined, that give you really interesting value props around hot and warm data, right? Very high performance, very linear scale-out. And then for cold, and if you have to do frozen, we'll accept it. We won't make fun of you much. But we'll use cold, and we use things like our scale-out NAS platform for Isilon. These platforms are really nicely designed because they are scale-out in architecture, so they abide Splunk scale, right? As you add servers, they can have this linear scalability. But they've decoupled compute from storage, right? Now we package those in very cost-effective scale-out consumption models. The first of which is really around our converged offerings, where we offer a real solution, true cloud-like experience, combining compute, network, and storage into an appliance whose each component can scale independently using these best-of-breed technologies from EMC, or if you're really interested in hyper-converged technologies, we offer those as well. And those technologies all bring together some interesting data services that make Splunk run better. One thing that we do really interestingly across many of the platforms is things like data at rest encryption. So if you want data at rest encryption, relying on storage to do that is a very effective, low overhead way to do that, and many of our platforms provide that. We also provide some interesting data services around snapshotting and data reduction. So especially if you're doing clustered indexing, right? We know that creates overhead and copies amongst the indexers. We have some very interesting data reduction technologies that can minimize the impact of that overhead in your infrastructure, okay? Now, to dig into that a little bit more detail, we have this thing called Xtremio. It is an all-flash appliance, super fast, all-flash, scales out, right? So you can start with one, and you can scale from there one brick at a time. And it does offer that self-encrypting drive. It has that cool snapshot and data reduction technology, but it's really fast, right? If you're in an organization where you want to improve Splunk search performance, this for your indexers can be very, very compelling, okay? And the data reduction at scale can be very compelling in terms of reducing your overall footprint, right? If I'm dealing with multiple copies of data because of indexer clustering, and I can reduce that by a large margin, not percentages, but X factors, that's pretty cool, especially at scale. If you're just really into software-defined storage, and by software-defined storage, I mean adding a layer of abstraction between the drives in your servers and the servers themselves. So think about it this way. If I've got 10 servers, each server only has access to its own drive in a traditional sort of DAS implementation. If I layer on something like Xtremio, I basically have a software running on all 10 of those servers, and I abstract those drives now away from the server, and I put this middle in place that basically says I'm going to now create a virtual SAN across all those drives in the server, aggregating the performance and capacity of those drives. It also allows you to do cool things like, instead of having to buy the same server over and over, you can have multiple different types of servers and have different storage pools within that server farm. So very cool in terms of scaling. Oh, I was showing you Isilon there, advanced on me. And Isilon is super cool for cold. So Scale.io, Xtremio, super cool for hot and warm, but also Isilon for cold. This is kind of a no-brainer for us. And it's really neat because Isilon is a scale-out NAS platform. So it exposes NFS and CIFS, and it actually exposes HDFS, if anyone wants to hear more about that. It's scale-out. Starts with 3 nodes, scales to 144 today. It'll be over 400 nodes by the end of the year. It's ultra-fast, so even if it's cold, it can still be very, very fast. But by using it for cold, you get around all the concerns around locking, which is great. But it's super fast. It has data reduction technologies. It has the ability to do data reduction around deduplication. But it's 68 petabytes today, over 100 petabytes by the end of the year in a single volume, single file system, single namespace. For you as an administrator of Splunk, what that means is I can have a single path for all cold buckets that I never have to go in and change when I run over my file system limit. Because if you're doing it on NAS today, you probably have like a 16 or a 100 terabyte file system limit. So once that gets too big, you kind of have a problem. We literally are a single volume, single file system, single namespace at 68 petabytes. That's like really cool, especially if you have large scale ingestion and long-term retention. Okay? And then we wouldn't be very cool if we didn't do the work of showing you how to put all this stuff together and make it work. So we've actually been working very hard over the last year to validate these architectures with Splunk and to spend time building reference architectures and appropriate solution documentation to help you deploy this effectively. These are all available online today. So we've tested this stuff, we've proven it out, and we've validated it works. Now, if you want to just consume this stuff in a cloud-like consumption model, meaning I just want to buy one SKU that I know just works for a 5 terabyte, 30-day retention hot and warm, 2 years on cold. If that's your requirement and you want one SKU, you come by from VCE. VCE, now called the Converged Platforms and Solution Division at EMC, takes basically data centers and builds them in a box. Cisco UCS or Dell server, right, best-of-breed server brands, Cisco networking, EMC storage technologies, combines them in a simple and easily deployed virtualized appliance. Very, very slick. The reason why you want to buy VCE for Splunk is because you don't want to buy infrastructure, you want to buy the SLA. I want this Splunk deployment to run awesome, and I don't want to talk to you about infrastructure. This is how you consume it, okay? So hopefully what we showed you is the ideal scenario is not scaling all the same way. It's that you can scale the right component at the right time dependent upon what is driving your requirements. Is that fair? So if you need more performance, you need more capacity, that's the whole concept here of decoupling compute from storage. Now, that's all about running Splunk on EMC. Guess what? You can actually Splunk your EMC gear. So we recognize the value of running Splunk better and building efficient systems. But we also realize that you all probably have EMC somewhere in your environment, and you would probably like to derive value from it. And oftentimes data onboarding can be challenging. We've actually gone out and created apps and TAs across our Xtremio, our Isilon, and our VNX platform to actually give you the ability to simply onboard data from those environments and begin to derive value from them. We give you out-of-the-box reporting that is useful, but it's kind of like a replacement to the existing storage reports you would probably have anyway. But what's really great is that it gives you a starting point. That's the beauty of Splunk, right? We start with this base set of applications and reports that give me somewhere to, okay, this makes the data more meaningful, and I can dig in and start to customize it and use it in a use case that's meaningful to me. So I highly encourage, these are free, and I highly encourage you to go check them out, and if you have cool use cases, let us know. So that was enough of me talking about marketing stuff. We're gonna jump to demo, and then we're gonna give you, after the demo, we're gonna give you a top 10 list of things you need to know about deploying Splunk on EMC. Cool? All right, Jenny, your turn.
All right, thanks, Cory. All right, thank you. All right, woohoo. So, so we're going to go through these two apps, and I'm going to start out with the Xtremio one. So again, Xtremio is the all-flash storage that is a great option for hot-warm tiers of Splunk. And you guys are probably very familiar with the Splunk main page driving into the app. So where I am here is the overview page for Xtremio. And essentially, this is going to give you an at-a-glance view of the Xtremio clusters that you've configured to have data collected for Splunk. So if we look through here, we've got the cluster names. These are things that you would expect to see of the XIOS version. This may be something that you want to make sure all of your clusters are running the same version, total capacity, volume count. And then with Xtremio's data reduction services, you also have some information about how much storage is being used and then how much savings you're getting from things like thin provisioning, data deduplication, and compression. Now, what's really nice is if you've written your own app, you know that when you save a search, typically, if you drill down into the visualization, it goes straight to the data. The nice thing about this app is if you click, you're going to be redirected into the appropriate dashboard for that particular cluster. So, oops, this is backwards. So with this cluster, we've drilled down, and we see a couple of panes. I'm just going to kind of scroll through this quickly. On the left-hand side, we see a summary. This is essentially what was on the first page. But there's one thing that's missing, which I think we can actually change in the main app. But for the purpose of this, I'm going to show you how you can customize that overview page very easily to make it more your own and reflect the information you're interested in. We also have a volume summary on the right. And then statistics about this cluster. Bandwidth, IOPS, latency. These are very typically questions that storage administrators will get asked. Hey, I have a problem. You want to come into a single pane of glass and be able to get some insight on what's going on with that environment. So with this, each of these dashboard, or each of these panels here is a short window of time which kind of tells you what's happened most recently. If you want to get a better understanding of what's happened, you can click on View Performance Details. It's going to drill down even further and give you the ability to change the time window that you're looking over. You can also change the cluster, but again, this is that drill down where it's going to auto-populate the cluster name based on what you said you were interested in, and then give you much more details about what's going on with that cluster. So this can be very, very easy now to kind of get a sense of what's happening. Spikes, potentially would indicate a problem. If we click back, and actually I also want to point out, if you notice, this opened up multiple tabs, so it makes it very easy to kind of navigate back and forth so you don't lose your place. I'm going to go ahead and close this window. Close this window and come back to the main one. So now I mentioned that when we drill down into one of these cluster summaries, there was also information about health, but that wasn't showing up on the main overview page. That would probably be a nice thing to know when you first come in is the state of my cluster healthy or not? So I'm going to show you how to do that. So with this, if you have power user privileges, you can go and say Edit, Panels, and you're now going to have more options to modify the contents of each of these panels. I'm going to click on the magnifying glass and say Edit Search String. And so right here, we have the search string that's already been written out. What you'll notice is table, and then you see cluster name, which is over here, Xtremio server. So these are the field names that it's displaying. I'm going to go ahead and add health here. And let's say I am not interested in the system start time. I'm going to take this out. Go ahead and hit save. Hit done. And so now when I come into the app, I'm able to see right away whether the clusters in my environment are healthy or not. So again, it's a great starting point, but it's really about what are you looking to do with your data, and then go ahead and customize it. Use this as a starting point to get the insight that you're looking for from your environment. Yes?
If I later upgrade to a newer version of this app, am I going to lose that data?
You won't lose that edit. The edits that you make, this goes into local. Excellent. Yep. Great question. Thank you. So repeating the question, he asked if you upgrade the app, will you lose the changes that I made here? No, those get saved into the local directory, which are preserved on upgrades. Okay, so that's the extent of the Xtremio app that I'm going to go through. Now I'm going to switch over to the Isilon app. And what I'm going to show here, so this is very similar. It's collecting the same types of performance stats and displaying them here. I'm going to focus on a new feature. This was actually kind of spearheaded. We got customer feedback, and then Simon O'Brien here, sitting in the front row, worked on creating an app. And it was so popular that it's been rolled into the main, the official Isilon app, and that is a file system audit capability. So I'm going to navigate over here into the security dropdown and look at the file system audit logs. This data is collected through syslog. There is a process of configuring your Isilon cluster to enable auditing and then specify where to send it. And so once you have that, you will be able to use this dashboard to get this kind of information. So this particular dashboard is just a report. So it's going to give you information on number of failed actions. So how many opens or deletes failed. This could be for a variety of reasons, permission denied, well, you name it. There's a number of reasons things could fail. So we have that reported. And the reason there's two panels here, one of them is, you can see this is trending. So this is going to give you a sense for how much change has happened this hour versus the last hour, and then today versus yesterday. So you can kind of get a sense of what's normal, what's not normal, and should you be concerned. We've got top accessed files, top client addresses, and then top failed reasons. So in terms of the count that I was just mentioning, we can mouse over here and see the object name already exists. Object name is not found. So anyway, this is very helpful information to kind of see what's going on. Most active users, and then top actions. So now if you want to start to investigate this information, you can click on security and go to the search facility. And by default, it's going to return all results that it has for the last 2 hours. And we can kind of scroll down here and just see the type of information that's in here. But if you know what you're looking for, or you want to inquire, like I want to see all of the delete requests, I can select that. It's going to re-search for that, and I can see, okay, here's the deletes that occurred. I could potentially say I want to see the deletes that were failed. Oops. You get the idea. Somebody might also say, hey, I'm trying to access this file and I can't access it. So it also has the option to search for a file by name. You can wildcard the name of the file, so you don't need to know the full path. Dare I? This is, by the way, this is Dean Jackson's lab environment in Australia, and he was gracious enough to let me play with it here. So thank you, Dean. And he's been doing a ton of work with Splunk. He's got a presentation. Dean and Simon are presenting tomorrow, right? So definitely check that out. But anyway, this is a very, very valuable tool. And if this is something that is of interest to you, definitely come by to talk with us and let us know what you're interested in. I think that is the extent of what I'd like to get.
Let's do the top 10. I'm going to have to hold this thing, so
all right.
Bear with me. Pretty cool, though, right? We're investing here. This is good stuff. All right. All right, here we go. As you can tell, that's us.
I'm the one with the beard.
Oh, thanks for
Okay, so
clarifying that.
yeah, no worries. So the goal here was we've been in this official relationship between Splunk and EMC for about 9 months, since about February of this year. And we've been implementing these technologies in a number of our customers, in a number of labs and validation environments. And what we figured out is there's some things that people want to know, just as best practices, like, hey, do this, don't do this. And so Jenny and I compiled a list of 10 things we think are awesome that you should definitely know to help you avoid any pitfalls. And some of them are really pretty standard stuff, but hopefully it'll make some sense to you. So the first one is, when in doubt, follow EMC's best practices. Now, again, this seems pretty obvious, but you'd be amazed at how many times, like, just some really basic best practices aren't followed. And do it across all platforms, right? We make these best practices available. And what I would tell you is we certainly make some very specific Splunk caveats where we make solution guides and we have these very specific things that we know about how Splunk operates. In the absence of one of those, follow the best practice and you will be much better off. And the same holds true for Splunk.
Yes, the correlate, exactly. Oh, let's see.
You can see me right here.
Yep, okay. So absolutely. So Splunk, you are probably familiar with this. We have a number of best practices published, things such as disabling transparent huge pages on Linux, increasing limit for the number of open files and the number of open processes. This is especially important when you're deploying something like the solutions that we have validated, because we recommend having more cores to take advantage of the performance of the storage. And when you have more cores, you can do more work with Splunk, and you need to increase that limit. Enable hyperthreading. There's been some confusion about this, about whether people should do this or not. Absolutely enable hyperthreading. Just make sure if it's in a virtual environment that you still allocate the equivalent of the number of physical required cores.
Yeah, don't go crazy. Like some server guys will be like, well, no, it's hyper-threaded. It's got like 4 times the number of cores. Don't assume that.
Yeah, no.
Don't assume that at all.
Don't do it.
We'll hang out to the, if you don't mind, we'll hang out to the end. All right. And then number 3, we were going to do this in Dave Letterman style, but it was going to get awkward to get the booth up here and everything. But anyways, number 3, slight changes in your Splunk configuration can have pretty big downstream impacts on infrastructure. So again, we talked about those levers that you can pull, right? If you change your retention period, if you change the volume that you're ingesting in an index, like, you kind of need to communicate that to your infrastructure team. So make sure that if there are large changes in the way you intend to roll out Splunk, that you engage with your infrastructure people and you have a conversation. If you're going to roll out a new app, understand it's going to have a performance impact. So maybe go ahead and start to talk with your infrastructure team. And I know this seems like it should be just like germane to your thought process, but you'd be amazed how many problems we've run into where it's literally just been massive scope creep that was never communicated. Okay? So be aware of that. When we talk about decoupling compute from storage, networking does matter. So use dedicated fabrics. So for hot and warm, we like FC SAN. It's awesome. And for cold and frozen, IP LAN is great. Use 10 gig. We do not like 1 gig. It is, we like to move data faster across the pipes. And we're not so far, and this is an opinion, we're not fans of converged networks at this point. We just haven't seen enough data that says that the performance is there for us to feel comfortable recommending them in our reference architectures. Now, on to networking, specifically in the Isilon space. Make sure you implement Isilon SmartConnect Advanced properly. I know I'm getting some high fives back there from dudes that dealt with customers that didn't understand what that meant. Here's what SmartConnect Advanced is. It's a load balancer. So instead of having all the traffic go down one node on an Isilon cluster that may have 50 NICs, like, you can configure it wrong if you don't take advantage of that load balancer that's native to that Isilon platform. You will send all your Splunk traffic down one network and you will call us and say, this Isilon thing really sucks. And we'll call you and say, well, is SmartConnect Advanced connected correctly? And you'll look at us and go, oh, crap, you did tell me that, didn't you? And then we'll fix it and you'll love it. It'll be great. Okay, so if you're going to virtualize this thing, which we love, virtualization is good, use vSphere 5.5 or later. So everyone know who that is? Johnny Manziel? Otherwise, it's not going to turn out as intended, right? I'm an Aggie, so I can make fun of him. Let's just be clear.
Yes, and on the VMware topic, if you're going to virtualize your environment, just make sure that you're allocating the equivalent of the physical resources that Splunk recommends.
Yep. And then definitely make sure that part of the reason why we want to use some of these later versions of VMware is it automates some of the space reclamation activities, and these decks will be made available. You can go to the links of these blogs, but it just really helps make sure that that data reduction technology gets fully utilized. And then, oh, by the way, if you decide that you want to benchmark this stuff, be aware traditional benchmarking tools that have been used around the Splunk community for a long time may not be exactly accurate when you're using virtualization and shared storage.
So let me provide a little bit more detail on that. Many of you are probably familiar with the recommendation to run Bonnie++ and make sure that your storage is getting at least 800 IOPS. That is not the best test for shared storage. We have customers that are running very large Splunk environments with shared storage, with Splunk, and we know it performs well, so really that reflects that the test is not appropriate for this. So we're working on better tools, but basically, if you are looking to understand whether EMC infrastructure or Dell EMC infrastructure is going to be appropriate for your Splunk environment, this is where you can look to the validated configurations that we have and trust that.
Yeah, so the validation process is really cool. So as I said, we've been in this relationship officially for 9 months between Splunk and EMC, and one of the things that came out of it was some really unique access to smart people like Jenny for us at Dell and EMC. And what we've been allowed to do is do some validation tools that they don't really release to a lot of vendors and do some interesting stuff to make sure the stuff works. And so what happens is we go build the environments that we think are maybe the right thing that looks like it might be a good solution for customers, and Splunk comes in and beats the snot out of it. And they make sure that it works and that it will publish. They'll publish and feel good publishing the statement that it meets or exceeds Splunk's reference hardware. So that hopefully gives you the comfort that we're doing the testing in the background to make sure that this stuff works and it works as expected and that they've tested it. And then if you use one of our reference architectures, you will absolutely get our commitment to your success. And I can outline lots of the things that we've done to make sure customers are successful, but generally it's a pretty good idea to use those validations. And then, as Jenny showed so well, go out and install those Splunk apps from EMC. They're free, they're kind of cool, but they're only really kind of the starting point.
So basically try them out. Let us know what your feedback is. What would be valuable to have in the app? As you can see, based on customer feedback, we were able to get a really cool feature implemented in the default app. So keep the feedback coming. Yeah.
I mean, they're free. It gets some value out of it. I think the value in the apps isn't necessarily the reporting. Like, that's okay. But candidly, it's a pretty similar reporting tool that we already have in native to the storage platform. What's really interesting, though, is that we're getting the data into Splunk so that you can use it against other data sets, right? It becomes that data platform. So use them, get creative with them, use them as a starting point. And if you have ideas for improvement, get active on Splunk community or Splunk Answers and start to make some of that stuff known. And then if you want to go talk about either deploying the apps or if you want to understand how to deploy Splunk and EMC together in your environment, I highly encourage you to reach out and talk to one of your Dell EMC Splunk ninjas. So all the folks in the blue shirts, they've been put through the same SC training that Splunk puts their SCs through. So they've been trained in the ways of Splunk, but guess what? They also know EMC and Dell pretty well. So they offer a really unique set of skills to you, and they're in the field in every market, so I don't care where you are on the globe. We've got 40 of these folks around the world. We've got them in every market. Reach out to us. These are some of the best SCs that Dell and EMC have to offer. These are really awesome, smart, engaged people. Don't let your heads get too big back there. I see you back there. But they're awesome. I mean, they really are. They're spending time investing in the community. We had 16 here last year. We have 16 again this year from around the world. And we're going to continue to be big players in this space and really committed to your success. And frankly, who doesn't love a ninja, right? Splunk.ninjas@emc.com will, if you don't know your EMC representative or you want to talk with one of us directly, just reach out and we'll be most happy to help. Thank you very much for hanging out. If you have any questions, we'll take them. All right, Tim, what's your question, bud?
So the hyper-thread,
Yes.
it adds 30% performance boost, but it appears in the operating system as double the cores, which means if I set the standard 1 search per core, 6 base, I'm going to see 38 concurrent searches allowed on that search head because it's going to see 32 logical processors, and it's going by logical, not by physical.
Correct.
It really should be 16 plus 6,
So it's
22 plus a 30% boost, right?
So that is actually okay. If you have a dedicated server and you're allocating all of those cores, hyper-threaded cores, to that instance, that calculation, you're still going to be fine. You're going to get good performance. It's not like so the specific concern is with VMware, where people will say, I see this, and I'm going to go ahead and,
Oversubscribe.
so that's really where the problem comes in. Using hyper-threading on a dedicated system, you still get a performance boost. So, and the sizing, the number of searches, it's still appropriate.
Because it's going to double the searches and it's only a 30% boost in performance.
You still get a performance boost by having that, so,
Yeah.
yeah.
Cool. Other
It's
questions?
just not double.
Yes, sir.
For NFS mounts for cold buckets, for optimization, is there anything Splunk specific as far as read size or write size?
We're using the basic NFS best practices on Isilon today.
Okay.
Yeah. Cool. Other questions? I'm so sorry. I'm such a jerk. He said, if we're doing NFS mounts on Isilon for cold storage, is there anything a Splunk caveat? And my comment is, no. We still use the same standard NFS v3 or v4, whichever version you're playing with, best practices that are published on EMC.com. I'm glad you asked. Thank you. I'm not very good at this thing. Any other questions? You had a question, sir.
We have high view environments that are using Isilon storage. They're interested in using the app, but they're scared to turn on auditing because it's going to impact performance of the Isilon. And I was wondering if in your solution guides and reference architecture, you've looked at that.
So there's two ways to collect that data.
Yeah.
One through syslog. Oh, I'm sorry.
Yeah, sorry.
Yeah. Thank you, Brian. The question was, they have a large Isilon environment. They're interested in turning on file system audit capabilities, but are concerned about the performance impact that would have on the Isilon cluster. Did I get that right?
Right.
Okay.
Typically, the high compute environments will, depend on fast read write.
Right. So there's two ways of collecting that data. One is through syslog, and one is through the common event enabler. The configuration that we're using is through syslog, and we haven't specifically looked at the impact of that, but it's syslog data, which essentially is negligible.
The TA, though, that we have that
Well,
actually
so, so there's two ways. So the TA actually has documentation. For getting all the performance metrics, the TA is going out to a REST API and pulling that data. For the file system audit capabilities, you actually have instructions that say go to the Isilon cluster and configure the syslog.conf to forward. So the TA is not actually doing that. You have to do that yourself. So it's a push.
apparently EMC has recommended against turning on the auditing because of. So I was just curious if you guys.
Really? Okay. I haven't seen that personally, and I'd be happy to talk with you. I haven't seen us recommend against it very often, if at all, but we certainly have some folks we can talk through that with you. I generally wouldn't be as concerned about it.
I actually wasn't a big follow.
Oh, okay, yeah.
Then you're in good hands.
But when you mentioned the reference architecture, I just came to mind. I was wondering if that.
Yeah. And then the pretty answer there is too, is if you're concerned about it, that's the brilliance of scale-out platforms, right? If you're concerned about the overhead, you add nodes, you add scale, and that's the beauty of why you choose something scale-out to support a scale-out app, right? Okay, other questions? Everybody enjoy the free beer?
Woo! I'm going to enjoy the free beer.
Thank y'all for being here.
Thank
Keep being
you.
awesome. See y'all.